2D. Here we have the integral of cosine of x over sine squared of x plus 10. It looks so complicated that surely we're going to need to do a u substitution here. So let's think about what the different possibilities are. One thing I'm noticing is that you've got a sine here and a cosine here. And the derivative of sine is cosine, and the derivative of cosine is sine, so, or negative sine rather, so that sounds like where we might want to go. It might be beneficial to consider some different choices for u. So suppose we decided to let u be the entire denominator. That's frequently what we want to do. So let's try letting u be the sine of x quantity squared plus 10. That's this. Now what's du going to be? Well, the derivative is going to be 2 times the sine of x using the power rule in combination with the chain rule. So the derivative of the outside function is going to be the 2 to the sine x to the first power, 2 times sine x to the first power, and then we need to multiply by the derivative of the inside function. That's cosine x dx. Well, we've got the cosine of x, but we don't have the sine of x. That could be a problem. Maybe that's not the way to go. Maybe maybe we could let u be just sine of x squared. But if we do that, then du is going to be exactly the same thing it was up here, because the only difference between this choice of u and this choice of u is the 10, and when you differentiate this, it's going to be the same. You're going to get the same derivative that you got up here. So I don't think that's going to be what we want to do either. That doesn't sound like it's going to be worth our while. So how about we then let u be maybe just sine of x? Then du is cosine of x dx. Well, that might work out fairly well. That'll give us du up here and u squared plus 10. Now, that does fit into one of the forms we've seen before. We know that the integral of du over u squared plus a squared, a is a constant, is going to be 1 over a times the arc tangent of u over a plus c. So that sounds doable. We have to decide what a is. Well, noticing the positions of the 10 and the a squared, I hope it's clear that a squared needs to be 10, which tells us that a is root 10. Alright, so this is then the integral of du over u squared plus root 10 squared, and that's going to work out very nicely for us. That's going to give us 1 over the square root of 10 times the arctangent of u, which is sine x over a, and we've got a solution.